All right, what's up, my mathletes? That's right, this is Mr. Muscarella coming at you. And in this video, I'm going to show you how to sketch a polynomial function if we know the zeros and we determine the y-intercept. So this is going to be our first example. And we've done this before, this particular example, in in an earlier video. So what I want you to do is kind of think about it from this perspective. So we know the roots or the x-intercept zero solutions, because remember, all of those mean the same thing. Now we're going to find the y-intercept and sketch the polynomial function. To find the y-intercept, we're going to have two options. We can use factored form or the standard form. So here we're given our zeros of 2, -3, and 1 for our first video, or our first example, and we're going to find the y-intercept and sketch the graph. Now when you go to find the y-intercept using factored form, you're just going to write it like this. So you're just going to plug in 0, because remember, any y-intercept has a coordinate of 0 and then some other number, because our x value is 0. So we're going to have 0 minus 2, and anywhere there's an x, you're just plugging in a 0. 0 plus 3 and 0 minus 1. When you simplify everything in the parentheses, you get -2 in the first parentheses, 3 in the second one, and -1. Combining those by multiplying, so the product of those three integers gives you 6. So cool. We just figured out that the coordinates for my y-intercept are 0, 6. Now, similarly, if I did that in standard form is going to be super simple because when we plug in 0, so if we plug in 0, again, we'll have 0 cubed plus 7 times 0 plus 6. And what's really nice is that all of the terms, like that's gone and that's gone, anything that has an x is going to be gone, and you're just going to be left with the constant, or in this case, 6. So again, we come up with 0, 6 for the coordinates of our y-intercept. So either way we did that, we got the same value, the same y-intercept of 0, 6. So those are the coordinates for my y-intercept. Now, once I know that, and again, standard form, super easy, just look at the constant. The constant will be the y-intercept. So some people might just kind of write that. They just might go f of 0 equals 6 and go right to there, because you're going to recognize, like, yeah, okay, I know that's going to be gone, that's going to be gone. When I plug in a 0, any term that has a variable, gone. All right, so let's talk about sketching. When you go to do your sketch, again, a sketch is a sketch, so it doesn't have to be completely accurate. We just want it to be relatively close. So I'm going to look first at the x-intercepts. So I have an x-intercept of 2, so I'm just going to go over to 2, put a dot, and that's my first x-intercept. My second x-intercept is at x equals -3, so I'm going to go 1, 2, -3 over there, and put a dot on that. And I want to put some numbers on my axis so somebody has an idea of my scale. And then I've got another x-intercept of 1. So those are my 3 x-intercepts. Now the last thing I'm going to do is plot my y-intercept. My y-intercept, we came up with the coordinates of 0, 6. So 1, 2, 3, 4, 5, 6. So say that's about there. All right. So those are the 4 dots that end up on my graph. 3 from the x-intercepts, 1 from the y-intercept. Now, in order to sketch it, I'm going to have to analyze two things. The first thing I'm going to analyze is when I look at the factored form right there, I'm going to notice the multiplicity. That's going to be one of the things I'm going to look at. Each one of those has a multiplicity of 1, which means when I draw this, I'm going to be passing through these. Now the second thing I'm going to look at is maybe in my standard form equation right here. I'm going to look at 2 pieces of that. I'm going to look at the leading coefficient and the degree. So when I look at the leading coefficient and the degree for my standard form version of this, then I can tell the general shape of the graph. Now the leading coefficient is positive, so that's cool, and my degree is odd. So I have a positive odd polynomial. Positive leading coefficient, odd degree polynomial, which means, generally speaking, the ends, so the most simple odd degree polynomial with a positive leading coefficient is a line. So the ends of the graph are going to kind of look like that positive slope part. So the first thing we're going to do is go to the leftmost 0, and we're going to sketch that part. So that's going to be like the bottom part of the line. That goes down that way. So cool. So we've got that. And then I'm going to go sketch the right side of my line. So the right side, so I'm going to go to the furthest 0 on the right, and that's going to be over here at x equals 2. So that's the first thing, that I do is I put the end behavior on based on the leading coefficient and the degree of our polynomial. Now from there, I just got to kind of connect the dots. Now since my multiplicity of all of these, again, I look at factored form, the multiplicity is 1, or an odd exponent for each one of my factors, which means every 0 it's going to pass through. So I'm going to start with x equals -3, so I'm going to pass through that, and then it's going to go up, and at some point it might be a little bit before it or after it, I don't really know where, but it's going to curve back down to come and intersect at the y-intercept. So then it's going to curve down and keep going down, it's going to pass through, and then somewhere it's going to curve and then come back up. So more or less, that's our sketch of our of our function that has zeros of 2, -3, and 1. All right, now of course we can verify that using Desmos. So let's go to the Desmos. So here we are. We can see you can see I've already kind of taken the liberty of putting that in there. So here's my factored form, and again, you want to use Desmos to check to make sure that your factored form and your standard form are correct. And you'll notice that because they are lined up over each other. Now I'm going to check my zeros, so I want it -3, +1, and +2, so that's cool. Got those correct. My zeros are correct, which I can always tell from my factored form. And then right here, notice there's always these gray dots at 3 different locations for polynomial functions. One is going to be on the x-axis, anywhere you have an x-intercept, so those are those 3 values. And then here on the y-axis, you'll see a gray dot there where the y-intercept is located. And 0, 6 matches the y-intercept we came up with. So generally speaking, yeah, that's what our graph looks like. Is that what we came up with? Yeah, pretty much. Now Desmos is really cool, so bonus tip coming at you here. If you click on the function, you'll see these other gray dots down here at the bottom at a turning point, or up here at the top at another turning point. More on that later, but I'm just going to kind of talk about it a little bit right now. So if you're at the top of a turning point, then you're going to be at a relative maximum. You're going to be at a maximum. Could be an absolute, but for right now, all you need to know is this would be a relative maximum. And then down here at the bottom, this turning point down here is going to be a relative minimum. So tops and bottoms of hills and valleys, and noticing where slopes change and you go from increasing to decreasing, but more on that stuff later. Right now I just want to make sure that you got the sketch pretty much matchy with what we came up with. So again, if we take a look at this picture and the one that we came up with, yep, pretty close. All right, that's why it's called a sketch, because that's all we need to be, is close. All right, cool. That's it for this video. Thank you guys for watching. I hope you have an amazing day, and don't forget to come back for the other couple of videos to make sure your work is good. All right, thanks very much for watching. I'll catch you later. Peace out.